Hey Geometry 2 students, Miss Craft here. Today's lesson is 11.1 dilations. We're going to start with some basic vocab. So a dilation is a transformation that preserves shape, betweenness, and orientation, but it does not preserve size. So you're either enlarging a figure or reducing it, and it is important to know the difference between the two. A dilation is made based on a scale factor, and a scale factor is found by simplifying the ratio of a segment of the image over a segment of the pre-image. Your image is the dilated figure, your pre-image is the first figure that you started with, and the way that we identify our scale factor is using the variable k. Okay, so properties of dilations. It's important to identify which segments are corresponding. So that's what I did here. I have segment RS because that's my image, so it has to be image over pre-image. So segment RS over LM has to be equal to the ratio of segment ST over MN, which has to be equal to the ratio of TU over NP, equal to the ratio of UV over PQ, and then equal to the ratio of VR over QL. So every single segment we have to compare. You can't just do two, and if that ratio is equal, then the figures are similar. So make sure that you're putting all of them together. So then I just plugged in the values for them, 4.8 over 3.2, 7.65 over 5.1, so on and so forth. And when I reduce each of those fractions, I get 3 over 2, 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 and 3 over 2. What that tells me is that RSTUV is a dilation of LMNPQ, and my scale factor, or K value, is 3 over 2. Because the absolute value of K is greater than 1, the dilation is an enlargement. It is possible to have a negative dilation, it just reflects the figure, so that's why it's important to identify the absolute value of K. The second example here, I have triangle WXY, triangle HJK, however you choose to label those. So I'm doing the same thing. I'm given the segments, so I need to identify the properties of my dilation, which is the sides proportional to all of its corresponding sides in the second figure. HJK is my dilation, so that needs to be the segments that are on top because it's image over pre-image. So I have 55 over 14 over 11 over 2, 10 over 14, and 1 over 7 over 5. It's important that you know how to reduce a fraction over a fraction, basically, and that is the denominator gets multiplied by its inverse. Some of you may know the vocabulary reciprocal. That's probably what most of you use, so I'm going to multiply each of these by 2 over 11. That gives me 5 over 7. 10 over 14 reduces to 5 over 7, and then do the same thing on the third fraction, 7 fifths. I'm going to multiply by 5 sevenths to the numerator and denominator, and I get 5 sevenths. Okay, so all of those are equal. And then, which means the dilation, or I'm sorry, that the triangle HJK is a dilation of triangle WYX. Make sure you're noting that corresponding points must be in the same position in your naming. So that's important also. And then because the absolute value of K is between 0 and 1, the dilation is a reduction. Okay, so those are your basic properties. You're looking for segment proportionality. Okay. Determining center and scale. Forgive my not super straight lines, but bear with me because I used a marker and a pencil. So what you're doing here is I've labeled each of these. First of all, the pre-image is the smaller image on the right this time, and the image is the larger figure on the left. So I labeled A, B, C, D, and E on my pre-image. That makes my image A prime, B prime, C prime, D prime, E prime. Okay, you're going to draw segments from your image to its corresponding point in the pre-image and draw those segments a long way through because it's harder or it's easier to determine the center of dilation if your segment from A prime to A is longer. Okay, so you're going to do that with all of these. So A prime to A, B prime to B, E prime to E, so on and so forth. Where all of those segments or lines intersect is your center of dilation. So I'm sorry, I should have marked that on here when I did it, but my center of dilation is here. Okay, then what I did was I measured the distance from the center of dilation to the pre-image and then the center of dilation to the image, like the corresponding point in the image. And I found that the scale factor is about 3. Another way to do this, because I wanted to check and make sure, just because my center of dilation is a little bit off, if you can see, like I missed, some of my segments are just a little off, I measured from this point here across the star to this point here, and then the corresponding segment in the pre-image, this point here to this point here, and it was 3. So you will have to print these out, measure and draw. It's not something that you can do. I attempted to do it using Notability and it doesn't work. So if you want these notes, you'll have to print them. Okay, I left 2 blanks here so that you can attempt those on your own, because it is important for you to be able to find the center of dilation. Finding the scale factor is not as common because when you take AZ Merit, it's going to be on a computer, so that's a little bit tougher. But identifying a center of dilation, you might have to pick a point, so you should be drawing those segments so that you know the general area of where that center of dilation will be. Okay. All right, dilating segments. The blue lines are what I've drawn. So you just have segment ZA and point P. And what I did was I drew segment PZ and I drew segment PA. Because my scale factor is 1/2, I know that PA is basically going to be 2x, and then I have to find A prime and Z prime, and that's going to give me a value of x. So basically what I'm doing is splitting this segment in half, hence my scale factor is 1/2. So I measured from P to A, and then I found halfway to that point. Again, you have to print this out. So in order to do that, if you wanted to practice, which I left this segment blank, I'll talk about these key points in a second, that would be for you to do. Okay. Really important to know when the center of dilation is not on a line, so like this here, P is not on segment ZA that we dilated, it creates a parallel segment. So Z prime A prime is parallel to segment ZA. Always, 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 that's one of our key things. So the distance between Z and A, the ratio of those would be the same as, Z prime and Z would be the same as A prime and A, and the lines are parallel. So betweenness is preserved, things like that. Over on this one, if you choose to do this one on your own, when the center of dilation, so I've asked you to use center of dilation M, you're going to measure from M to L and multiply it by 3. I apologize, it is going to go off the paper from M to N because I wasn't thinking. But when the center of dilation is on the segment, then the lines are coinciding. That means all that's going to happen is your segment is going to extend, but it will be on the same segment LN, so it'll just be longer, basically. All right, I'll have to come back to these coordinate rules for dilation because you really won't see anything other than a center at the origin, and I apologize, you're just multiplying your scale factor, if you look in my example, by each point. So if you wanted to write here in parentheses, it would be kx comma ky. So my scale factor times my x value and my scale factor times my y value. That's how you get that. The center not at the origin is a little bit more difficult, so I don't want to just say it. I'd rather write it, and again, I can come back to that later. For dilations on a coordinate plane, my scale factor here is -2, so this is what I want to make sure you know. That creates a reflection. So I'm multiplying to find f prime. I'm doing -2 times f, coordinate x coordinate of f, and y coordinate of f. So that's what this is, -2 times -4 and -2 times -2. Same thing for g prime and h prime, I just multiply. And then I simplify those, and I got the points f prime are 8, 4, g prime is 4, -8, and h prime is 4, 4. Again, if you notice, this is a reflection or a rotation of 180 degrees, if that's how you choose to look at that. And that would be how you dilate using the center 0, 0. So multiplying, it is twice the distance away. If I count here, I'm 1, 2 to this segment. If I count this one, I'm 4 spaces away to my dilated figure. Okay, so that is your 11.1 notes. If you have any questions, please send me a message. Thanks. Have a great day.